Second one is reader's writer problem. Okay, just I'm giving you one example. Assume in the classroom. Okay, I'm teaching in the classroom. I'm teaching using the blackboard, of course, green board and white chalk. I'm teaching, and you are sitting in the benches. Okay, listen carefully. I am writing some statements on the board. Okay, for example, I have written one algorithm on the board. How many persons can read at a time? Okay, how many persons can read the algorithm at a time? All the 45 persons available in the class can read the algorithm at any given time. Okay, that means what? More than one person can read the content at any given time. One person or two person or 10 persons or even 60 persons can read at a time in parallel. Okay, how many persons can write on the board at any given time? Of course, if I give 10. Now, how many persons can read this? All the 180 persons, okay, all the 130 persons available now at present in the link can read this. Okay, if I am asking you to change the value of A, now how many will do? Only one person can do. Okay, because I am having the control, so I can modify. You are presenting means you can modify. X is presenting means only X can modify. Okay, that means writing can be done. Writing means what? Modifying or updating or changing can be done by only one person at a time. Okay, that means what? I am just giving the concept. At the time of reading, writing should not happen. At the time of writing, reading should not happen. Like producer consumer, when producer is producing a job, consumer have to wait. When consumer is consuming the job, producer has to wait. Okay, when they are sharing common variable counter, same thing. When a process wants to read some data, writer should not be allowed. When a process is writing the data, reader should not be allowed. Now I am asking you one question. When a process is reading the data, another reading is allowed or not? Any one of you reply in the chat box. The value, any number of process can read the value in parallel. Okay, underline the word in parallel. Okay. Now the question is, when one person is writing, can other person also can write? That means when one process is modifying the value, can other process also modify the value? Quickly answer in the chat box. Reading, all other processes are allowed to read. Okay. When one process is reading, other process not allowed to write. When one process is writing, other process not allowed to read. When one process is writing, other process not allowed to write. So only possible when one process is reading, other process also can read the process. Okay, now listen this algorithm carefully. Writer process is very, very simple. When I am going to write, I will just ask all persons to wait. All persons to wait means what? Those who are requesting for read as well as those who are requesting for write, all should wait. Okay, some process may give request to read. Some process may give request to write. Whoever it may be, if I am going to write, that means what? If P1 is going to modify the value of A, all others P2 to P1 must wait. Okay. P2 to P1 all must wait at the time of writing is performed. Okay. After writing is over, I can signal for writing as well as reading. Okay, you're able to understand? So writer's problem is very simple. Before I am going to write, I will ask all others to wait, whether reading or writing. I will write or I will modify the value and I will come out of the critical section. Now whoever wants to read or write, you can go. This is for writer process. Okay. Quickly go through the signal reader process. Okay. Listen carefully. First, I am asking for waiting mutual exclusion. That means what? Already I told, when one process is reading, other process cannot write. When one process is writing, other process cannot read. So that mutual exclusion must be maintained first. So when I am going to read, what is not allowed? Writing is not allowed. That I have to wait first. Able to understand? When I am going to read, other writing is not possible. To say it, I am just writing. Okay. P1 is going to read. So P2 to Pn not able to write, or they are not allowed to write. So I am calling the wait signal call. Okay. Now listen carefully. What is happening here? Read count plus plus. That means what? After making this call, I am counting how many read request is there. Okay, read count plus plus. That means what? I am counting, or I am incrementing the readers count by one. Already, for example, 10% is request for reading. Already they are in waiting to read. Now I am adding one more. This is my request. So now read count will become 11. Okay, read count will become 11. Okay. Now here, or suppose as we are talking about only two process, P1 and P2. If you are talking about only two process, 0 and 1, that's all. Okay, if you are talking more process, you can increment the reader count. Okay. Now here, if you see, if read count equal to 1, that means what? If read count is at least equal to 1, wait for writing. Writer should not wait. Sorry, writer should not be allowed. Able to understand? At least one person is going to read the value. You cannot write. So I am asking writer process to wait. Already here, what for waiting? When reading is performed, writing is not allowed. When writing is performed, reading is not allowed. So reader process is executing. So writer process is not allowed. And if read count is at least equal to 1, and all write process must wait. Okay. Then once the waiting is over, I am signaling for mutex. Okay, signaling for mutex means what? Whether it is reader process or a writer process, they can read the value. Okay, whether it is a reading process or a writing process, they can read the value, but they cannot write the value. Okay. Now again mutual exclusion, I am using wait, then read count is decremented. For every action, this read count will be decremented one by one. Once the read count is equal to 0, now signal of write. Then finally signal of mutex. Okay, to say it very simple, before I am going to read, a process wants to read means before going to it, OS is giving permission for reading. Okay, before going to read, I am stopping mutual exclusion. Writing is not performed. Okay, don't modify the value. Writing is not performed. Okay, after entering into critical section, I am reading the count of readers request. If the reader's request count is 10, I am asking writer to wait. Then read 1 is performed. Writer to wait. Read 2 is performed. Writer to wait. Read 3, read 4, read 5, read. So every time it will be decremented. Once read count is equal to 0, I can signal for write. Okay, now you can write the value or you can modify the value. Then you can perform mutual exclusion also, because writing is also allowed, reading is also allowed after next stage. Okay.